Hi, this is Tutor Buxton. Welcome to my channel. Today I would like us to move into estimation for the wallings of a superstructure of a high-story building. Today what I would like us to continue with is how to do the measurements, how to take the quantities, reading it from plan and so on. Over the past few sessions we've got a privilege to learn preparation of bills of quantities, and the rest of the videos will be attached as a playlist onto the description of this very video. Welcome. When you want to estimate walling, the rule for estimation, that is from the standard methods of measurements, tells us that we need to do it in square meters. So square meters, what matters most is how to get the center line, which we had learned previously in one of our sessions, but it will be reinstated here, or let me say emphasized for that matter, so that those who are new to the channel will be able to get it better and so on. In estimation, in our taking off for the walls, it's always important that we start with the external walls and then we move to the internal walls. The reason for dividing these walls this way is because, one, the rule states so, and then two, there's a possibility that those given walls, for example the external walls, are going to be finished differently from the internal walls. External and the internal walls will be finished differently, and normally the reason of doing your work is, of course, being able to estimate in terms of cost. And then as a professional, your other aim is to make sure that your work can easily be interpreted by another party, a third party, who is going through your work. So when you do it in that order, it's normally going to be very easy for somebody to follow up what actually was undertaken in this point. And then when you now start to mix them up, you do internal walls and the external walls all together. Then at the finishes point, you're going now to also, you need to finish, you no need to measure the finishes for the external walls separately and then the internal walls separately. So when you combine them at the walling structure section and then at the finishes section is now when you want to separate them, it's not going to be very easy for somebody to make a follow-up. So what we are using here is what we call the Excel, and in this Excel we also learn how to make edits, how we can edit it and use it in our own advantage, because Excel has got various functions or various ways in which you can use it to make our work very easier. So what we do, because we had edited some items here in the previous work, so what we can do is just by copying, we can copy a bit of it. For instance, I can copy just like those few lines. Once you copy that, then you paste it here. Okay, you paste it here, and once you've done that, of course I'll make the edits because I want to use the side for my calculations. So I can do what you call, I can just highlight all of that, and then I want to deselect this point. So while holding your control button, then you select that other part, and of course now I want to delete really, that is not what I want. No, I want to delete the items to the side there. So once they're selected, I'll just delete that way, and that one is gone. Okay, you can see my lines here, they are hanging, but that is not what I want. So I'll just move till the end of this page. Of course I want to use the whole of the page, so what I can do, I can just select the whole of this, the whole of that way, then I right click. So when you right click, some editing tips here, then go to format cells, then as it formats, when that comes, so I need these lines, I need the lines here. Alright, that way. Then you, okay, actually I didn't want the other smaller numerous lines, so instead I'll select again and then get to format, I'll remove these ones because they become so many and it's not very okay. And then of course for this title I needed to have those dark bold thick outside borders, so I select that one, and that is there. So I'll go to walling. That is for the description of the walling. Alright, and then yeah, I can do away with these other ones that I don't need now. I just needed that structure. Alright, then this is square meters because I need the wall in square meters, and then this part for columns, I mean that beams, I'll do away with it. So this is walling. Normally the most important thing when you're describing your wall is to state the thickness. What is the thickness of that particular wall? And of course now which kind of material, in terms of there are various ways of building a wall. So which type of wall is it and what type of material has been used. Okay, so that's the simple way of making up your description. So how do you get your thickness? That you read straight away from the plan. So the plan, for instance, the one that I'm having here is stated, or it's indicated. There is 200 here because this is where the wall is. Okay, so from this plan there are various ways in which different architects can represent walls on drawing or working drawing for that matter. So in this case, the dark ones, you can see there are these dark. Yeah, from here you can see whichever element that is identifying the spaces. For instance, when you look at the bedroom, you will see there are the dark line or dark elements here. That is what the wall is. So it will depend from one architect to the other. There are those that would like to represent the walls maybe just in 2 lines. Okay, I mean lines identifying the wall, and then there are crosses in between. So that is another way, but for now what we are using here, it's shown in the dark shade to represent the walls. And when you look at it properly, there is this line. For instance, here it's showing 0.2, which is 200. Normally you might find that they are interchanging from one wall to the other. Okay, in the sense that maybe the external wall or most of the walls are 200 thick, but then you might find that walls that are identifying the washrooms or the restrooms, for instance, might be 150 millimeters thick. So you have to be keen and identify all the walls, the ones that are 200 millimeters thick and those that are 150 millimeters thick, which. So you need to identify that so that you don't leave any of them out, or you don't categorize all of them as walls of 200, yet there are those that are 150. So saying that said, so this is 200 millimeters thick. Okay, so in this case, so that you know which type of description that you are going to put, there's normally you can always refer to the sections or the details so that you are sure of the type of material that have been used for that particular wall. So I'll just get us to the section or elevation so that we are just able to check what is the definite description of this type of walls. So having checked, now this is the section. I was just going through to confirm the description of the wall. Apparently I can't find it, so we'll make an assumption, or we will describe based on the standard wall that might be used. So there are those cases in which you can use natural stone walls for the external walls and then machine cut walls for the internal walls. So I will take that direction. So for instance, but this being an apartment, I can just use machine cut ordinary walls. So I'll state 200 millimeters thick, masonry walling, masonry walls in cement stroke sand 1 to 3 mortar externally. So the few items, the few important aspects of this description that you must consider is that first you are stating the thickness of the particular wall you're dealing with, okay? Then 2, material, then how it has been bonded, how exactly that wall is going to be built. That is now the jointing, jointing in mortar, cement, sand, 1 to 3, mortar. Okay, you can then go ahead and state with every alternating courses in hoop iron. Okay, that is just to reinforce the wall, so you have to state how the walls have been reinforced. So that is 12mm thick masonry walls in cement, sand, 1 to 3 mortar with every alternating courses in hoop iron externally. So that is just to mean for the external walls. So once you say that, then the unit is square meters, and then now the next item to be done is as finding the quantity. So that is what we are looking at now. Quantity of that, let me see. Yes, here we are. So we need to find the total length of all the walls that you're dealing with, but we'll start with the external walls. And the external walls, we get the center line of that, get the area, and then find the net of the same, the net area of that external wall. So normally the easiest way is to find, start from a corner. You can always identify which corner that you want to start with for this particular building, and then you get let me see, in this case there is a 12.6. all right, so regardless of the shape, from my previous explanation when I was finding the center line for some of the plans that we've worked on previously, you find that regardless of the shape, you can always refer to this as a perfect rectangle, and then you're going to do adjustments for for the recesses and also the extensions. When you do that, it becomes easier to achieve your area or your center line without trouble. So what I'm saying is, for instance, looking at this, you see this is we are doing our example using what we call, this is now typical floor plan, which is replicated in different floors or in numerous floors. Okay, so once you know that, then this for the external part, alright, so I just want to zoom in because you can see that there is a wall here. Okay, this is a long grid, grid F. Let me do away with this so that you're able to see, or alternatively, let me just if I take it that way, you can also able to see as well. So what I'm saying, this is now on grid F1. So along grid F1, you can see there is part of wall that is recessing at that point. So it means we are going to also take into consideration of that. So what our best approach to get these the dimensions, the center lines calculated here, is one, get the total external length, from one point to the other. So when you refer to this from the extreme right, left of my screen, that is, if you're right-handed, that is, there is a 12.6 starting from all the way from the beginning to all the way to the end, left to right, and it's including the external faces of that particular wall. So I'll take 12.6. so this is how to get my center line. So I'll have indicated this as center line, So what we have here is 12.6. Okay, and then from the 12.6, the next thing is the next dimension. Just check here. You can always find that most extreme dimensions when it's indicated. Okay, so like this one, I can see there is an indication of 9.4 starting from the bottom all the way to the top. So it includes also the external faces of the wall, just like the one that we've done at the length or the longer part. Okay, so the 12.6, then we add the other one is just zoom it in, 9.4. the other is including all the walls to the extreme points is 9.4. so I will add 9.4 there, and when I do so, I told you that I want to consider this as a perfect rectangle. I'll multiply that by 2. Okay, once you multiply that by 2, then I want to consider which are now the recesses and the extensions. Okay, so that I see whatever that might be have been left out, then I add it to what I've already got. Okay, so starting from the point where I started taking my dimensions, if you consider this particular recess here, let me see if I can get my pencil to draw, that I'm able to explain what I mean. Let me see. Yes. All right. So there is this point. Where I'm showing there, at that point that I'm showing with a T, not really, yes, so you see that part there where I'm showing with my cursor with the indication of a T. At that particular corner, those walls can be dragged on either side to fill that point. So it means that it's neither an extension or a recess, but then it can be filled. It can use that. It can make up for the other parts that have been taken in our dimension, in the sense that there is no difference whether you take it full as a perfect corner or as an indented corner. There is no difference in terms of the dimension. It still gives you one and the same thing. Okay, so looking at it just in imagination or in ideal interpretation, if you take this first portion moving downwards and then you substitute it to the side, that becomes full. Then you do the same, the one at the top, then you drag it downwards, that becomes full. So ideally, that is the explanation behind taking it as complete. All right, but when I'm here, there is a wall at this point. Okay, and this particular wall, you can also stretch it downwards, then it will fill, this is it will fill the length at h1. Okay, so which one of it is also considered an external wall but might be left outside. Okay, now there is you can consider the whole of this as a recess, and when you do so, the wall here and the wall here will be hanging, so you need to adjust for that. So you need to add those two areas that are left out, and those two areas, the dimensions is going to be, now there is one for 600 and 400. Okay, because it comes from grid H1 to F1, and the other one is for 600 to the smaller one outside, and then 400 to the part at the part that is just next to it, making the whole of this particular wall which I'm talking about. So the whole of that is becoming 1. okay, then it's 1 times 2. Alright, so that's noted. This other part, the same explanation. Then we have another recess here, and this recess here, the vertical line, the one where I'm moving along with my cursor, can be transferred to the side. It becomes complete. But then there is this portion here, the 0.6, to the bottom and to the top, cannot be transferred. So they are left out. So I'll add 0.6 times 2. Alright, then moving upwards, this one we've solved it. This other extension here is also solved because we took the whole of dimension to the external faces of that particular wall. So that is solved. Then this one is not solved. There's another recess here. You can transfer literally this point, that dimension, to the side, but you can't transfer the dimension here and the dimension here anywhere. So I'll need to add another 0.6, another 0.6 times 2. So once you have this total length, because we took it to the faces of the external walls, then we now need to subtract the corners because we are looking for the center lines. So we need to subtract corners, which in our explanation in one of the videos that we did previously would mean just adjusting the wall that you've calculated either from the internal face or the external face, so that you adjust it to be from the center of that particular wall, because we need to get our center line in our calculation of the areas of the wall. So we'll take instead, we've done the rest, and the wall in this case is 200. So it's normally the thickness of the whole wall, or half of that wall, times the 4 corners. Okay, in the sense that half of the wall, in every half of the wall you will multiply it by 2, because on one point, on one corner of the walls, you should be able to move inwards by half on both directions. So on the top line, on the top wall, you should be able to be moving inwards by half, so that you get to that half of that point. And then on the vertical wall, you also need to move by half. So ideally it's normally half, which is now 0.5 times the wall thickness is 0.2, okay, and then you multiply by 2 times 4 corners. So regardless of how many corners that you have, you always refer to the 4 corners, okay, which you've taken as half of that thickness of that wall, twice for every corner, and then times 4 for the corners. All right. Now once you have your center line correctly done, which is the most important thing, then you will consider also going to now interpret from the sections to find what is the height to be used, because basically we are looking for the area of the wall, and the dimension that you'll need, one, for external walls you'll need your center line, and then you'll also need your height. Okay, now for that, let's see if we have a section here. Then from the section you're able to get the height. So if you didn't have it, then you have to look for where the section of the building is. That is what is going to guide you in finding what your height of the building is going to be. Normally when you are calculating when you're looking for the height, you'll always find there is that complete depending on the way the dimensions have been given, you might be provided with the full dimension from floor to floor. That will be including your slab and also the beams. But then you realize that your walls are going to be, the height of those walls is normally up to the soffit of the beam. Okay, so when I zoom this, if I zoom this in, you are able to see that from the top of the slab, where now the wall is, the wall that we are talking about, up to the soffit of the beam is 2.55. So that is always the height to use. So even if it's provided from floor to floor, then you need to subtract your slab the thickness for the slab and also the thickness for the beam that is in that particular structure. So in this case, it's given straight away, and it's 2.55. Okay, so the height is 2.55, so I'll take equal to the center line that you've already calculated times 2.55. When you do this gives you the gross area of the wall, but remember that you always want to have what we call the net area for your walling. So net area would mean the next step after you've calculated the gross area, then you need to subtract the openings. That is what the standard methods of measurement is instructing us to do, or is giving has been guided. So basically, after you've calculated your gross area, which is now the area inclusive of the openings, then you need to adjust by subtracting the areas for those openings. So one way that you can do that, just to mention, is for one, you can use the window schedule or the doors schedule. So when you have that, then you're able to know the dimensions of the particular walls or the particular windows that you have in that particular building. But when they are not given, alternative is you are always allowed to do what we call use of the standard sizes, of which sometimes doesn't apply. Sometimes it doesn't apply for the windows, but it might apply for the doors. Okay, depending on where you are, maybe you can take the doors as 900 by 2400, so you can always subtract those areas as a standard for the doors. But in this case, the one that we are using, let's check if at all. In this case, there was no schedule for the openings. So in that